But why would the heart want to do that? What's the advantage? Because it does it itself. Unlike we had to drive this motor at a certain frequency, we had to rotate this at a certain rate, the heart kind of finds itself in this position itself. Nature likes it between complete order, complete chaos. Well, first of all, how does it get there? Well, with the heart, there are many body clocks. There are regular contractions of muscles. There are physiological chemical clocks. And all of these are working together or competing at the same time. Now, they feed off each other. There's a kind of feedback between them. But the body, by not relying on any one particular clock, it seems, scientists think at the moment, that actually this is an advantage because it makes the heart more adaptable, kind of self-organizes itself and kind of controls itself without any outside overall clock determining the rate of beating. So there's a kind of advantage in not being too regular and being slightly unpredictable. Actually, this is interesting because we think of health as order and illness as disorder. And so it's beginning to open questions about exactly what we mean by order and disorder in terms of health. It's not just in the body as well. It also seems that in things that we like in the arts, we like things that are slightly irregular. Take, for example, music. Turns out that if you look at, for example, a piece of Bach, and you look at the patterns in time in the music, that they follow very similar mathematics to the mathematics that describes, for example, the sand, the avalanches in the sand, or the irregularities in the heart. It seems that we almost like music that kind of reflects nature, the kind of maths that's in nature. We seem to kind of like that. And it actually makes sense, because if music's too ordered, of course, it's boring. If it's too disordered, we somehow can't connect to it. And it's this middle ground, this kind of edge of predictability that we find interesting. So it's also true in our daily behavior. I mean, you wouldn't, if you go out and get the bus at 8 o'clock every morning, you know that you've got to be slightly adaptable. You don't just step out into the road at 8 o'clock every morning, hoping that there's a bus there. You know you have to adapt. So that's in terms of us as individuals. What about us as a group? This is an exciting new area of science, which is looking at the collective action of a group of people. Well, one of the things that I mentioned at the beginning of the lecture was the problem of traffic. Now, if you think about it, traffic and the flow of traffic along a road is actually very similar to the flow of sand. Sand's made up of grains, and they flow in a given direction. So is there any similarity between the two? Well, to investigate this, we need to look at some traffic, and I need a volunteer to help me. Would you come down? Your name is?
Dean.
Dean. Just stand there. You're controlling the front end of a traffic jam, Dean. So we're going to set up our traffic jam here. What I want you to do is, when a car arrives at the back, just pull off a car at the front and pull it along the road. Okay, so first car coming in. Second car. Carry on. What you can see is the traffic jam moves backwards along the road. That's it. Okay, thanks very much, Dean. So traffic jams move backwards along a road. Now we actually have some real traffic data here, taken from a section of the M25. Now here we have the section between junction 10, junction 15. Cars flow in this direction along the road. And this is a snapshot of the traffic. Now, the dark regions are where the traffic is moving very slowly. So you can think of it as a traffic jam. And the light regions are where the traffic's moving reasonably quickly. So there's no traffic jam there. And this was taken at 8 o'clock in the morning. Now, as time moves on, of course, we just saw traffic jams move on. And so if I slide this along, you can actually see, let's just take one traffic jam, it's black in the center here, you can actually see it move backwards along the road. Now, of course, no one driver has knowledge of what's happening on the whole road. But if we look at the pattern that's formed along the road for all time, we begin to see something that does indeed resemble some kind of pattern, not completely dissimilar from the patterns, the lines we're getting on these mixed grains that are rotating around there. And this pattern isn't completely regular, but it isn't completely irregular. If it was disordered, then the black and the white would be smeared out all over the place. They'd just be completely disorganized. But we can see some kind of ordering there. And it's understanding these kind of patterns and the realization that the patterns that occur in things like traffic are very similar to the patterns that occur in, for example, in sand and in many other things in nature, that's giving scientists an understanding about what happens in time in these systems. And that's the key then to giving some level of predictability about the future. But of course we're humans. We don't always behave rationally. We drive along, we don't necessarily make the most of the situation that arises. We carry on the road. We have limited information about what all the other drivers are doing, and we have choices. And it's these choices that I now want to look at. How do we make choices? I need 4 volunteers. Could I have you 4 here? No. No, you. And one more.